You remember how in our last lesson we talked about perpendicular bisectors? This isn't my essential question. So I'm not going to write it there. I know you never write a question, but you really should. So our last lesson we talked about perpendicular and angle bisectors, right? So here's a repeat of the perpendicular bisector definition. A perpendicular bisector is a line, ray, or segment that is perpendicular to a side of the triangle at the midpoint of the side. Well, this is a little bit different. This is a perpendicular bisector of a triangle. So perpendicular. So of course, since we have three sides of a triangle, we know we could have three perpendicular bisectors for a triangle. So let me just show you here. If I got a triangle, perpendicular bisector, let's see, perpendicular bisector, then I could have one, let's see, that would be a perpendicular bisector, and then I'd have one over here, and that would look like so. So I got three perpendicular bisectors for every triangle. And then, as you can see, all three of these lines that I've just drawn, all three of these perpendicular bisectors, they're going to intersect somewhere. And anytime you have three or more lines that intersect in a point, they are called concurrent. They're concurrent lines, and the point where they intersect is, appropriately enough, the point of concurrency. So, my point of intersection right there, that's the point of concurrency, right there, of those perpendicular bisectors. And that has a special name. The point of concurrency of the perpendicular bisectors is called a triangle's circumcenter. Point of concurrency of the perpendicular bisectors of the triangle is the circumcenter. So that right there is our circumcenter. Okay, and we have a theorem related to that. Concurrency of perpendicular bisectors theorem says the perpendicular bisectors of a triangle are concurrent at a point that is equidistant. Oops, I spelled that wrong. Equidistant from the vertices. So if this, let's say for instance in this triangle, P is our circumcenter, it's equidistant from the vertices, therefore I know that PA equals PB equals PC. Circumcenter is equidistant from the vertices of a triangle. You better have a flashcard that says that on it. Okay, now look at the little diagram I put in here. The circumcenter of a triangle can be inside, on, or outside a triangle. Look at this case. If I have an acute triangle, circumcenter will always be inside. If I have a right triangle, the circumcenter will always be on. And what will that point be right there? Oh, because I know it's the point of concurrency of the perpendicular bisectors. If I got a right triangle, I know the circumcenter is on the midpoint of the hypotenuse. Boy, oh boy, you better remember that. And you know what, guys? If you'll take a minute and think about it, and you'll understand why that is the case, then it's not so hard to memorize. Okay? Circumcenter of a right triangle is at the midpoint of the hypotenuse. And if I got an obtuse triangle, then the circumcenter is always going to be outside of the triangle. So let's look at this one I sketched up here. It looks like almost that I drew a right triangle, but I think the circumcenter is a little bit outside of this triangle, so that means that's got to be an obtuse triangle. So if I gave you a sketch and I drew all the perpendicular bisectors, you could look at where the circumcenter is and tell me whether that's an acute, right, or obtuse triangle. Look at something else really special here. You see in this picture here, I'm going to go around it. Of course, I can't do it really accurately because I don't have a compass, but I'm going to give it a go. So what happens is, guys, when you find the circumcenter of a triangle, okay, and we know that that circumcenter is equidistant from each vertex of that triangle. If I were to take my compass and make PA, PB, or PC the radius and then draw a circle, that triangle is going to fit perfectly within that circle with each of its vertices intersecting the circle. And what that's called is this circle is circumscribed, not to be confused with circumcised, circumscribed about the triangle. So every time you find the circumcenter of a triangle, you will be able to circumscribe a circle about that triangle. This unit, although it's got tedious problems and a lot of terminology, and a lot of you won't like it, for those of you who do love math, there is just some fascinating things that you will learn about triangles in this unit. Okay, so why don't you do this? Why don't you practice on each one of these triangles down here? Take your compass, put the point on the circumcenter, open it up so that your pencil is on one of the vertices of the triangle, and draw the circle. See if you can circumscribe the circle about each one of those triangles. I bet you can. Okay, what do we got next here? A bisector of an angle. Okay, we talked about angle bisectors, right, last time? Well, if I bisect an angle of a triangle, bisector, it divides the angle into two congruent angles. And of course, we know that bisector of an angle of a triangle. Somehow I'm thinking that's not what I wanted to write in that blank, but I can't think of something different, so we're going to go with that. Okay, so let's draw ourselves a triangle here. And of course, I can have three bisectors, three angle bisectors. So let's draw them in here. So there they are. So I know that's congruent to that. That's congruent to that. That's congruent to that, because I'm talking about angle bisectors now. And as you can see, all three of those bisectors are concurrent. There's a point of concurrency, and for the angle bisectors, that point of concurrency is called the triangle's incenter. Triangle's incenter. Okay? Now there's a theorem about the incenter. The bisectors of the angles of a triangle are concurrent at a point, and that point is called the incenter. Let me tell you something, guys. Every chance I get, I'm going to write this down because it just helps me remember the language better. That incenter is equidistant from the sides of the triangle. And of course, remember, it's got to be a perpendicular distance. So PD is going to be equal to PE is going to be equal to PF, because that theorem tells us so. For any triangle, the incenter is always inside. You remember the circumcenter could be outside, inside, or on. Incenter will always be inside. Okay, let's see what we got here. We got a few practice problems. So I'll do one, and then I'm going to let you do the rest of them. Here we go. The perpendicular bisectors of, so I'm going to start right. Perpendicular bisectors, What did the theorem tell me? It told me they're equidistant. I mean the circumcenter. So I know that's going to be the circumcenter. I promise you guys, if you'll write this every time you get a problem, it'll help you to remember it. So I'm going to be talking about the circumcenter. What do I know about the circumcenter? It's equidistant from the vertices, right, of the triangle. That's how I get that circumscribed circle. Vertices. It's hard for me to spell and talk at the same time. Okay, so I'm going to be talking about the circumcenter. I know the circumcenter is equidistant from the vertices. So here is my circumcenter. Find PS. Where's PS? PS is this distance right here. And QS is this distance right here. Okay, what do I know? I know that they're going to be the same as RS. So there's it. Wow, that was easy enough. But you see how they threw in all that extra information that I didn't need just to confuse me? So if I get myself going straight before I even start, I'm not going to have a lot of trouble. So I know that PS is going to be the same as QS. It's going to be the same as RS, which is 10. That's simple enough. Okay, I want you to pause here now. Oh, look, this one, we got the angle bisectors. What's that point of concurrency? That's the incenter. And what does the theorem about the incenter tell us? It tells us that the incenter is equidistant from the sides of the triangles. So there's your hint. Stop right there and work this problem and the next one. Okay, so in this problem, like I said, we got the angle bisectors. We know that their point of concurrency is going to be the incenter, and we know that the incenter is equidistant from the sides. I'm going to write that over and over till it's stuck in my head. So I know that Wx is going to equal Wy is going to equal Wz, and they give me the links for two of those. So I just set them equal, and I find out that D is 4, and then I plug that into either one of these equations, and I would get that all three of those segments measure 15 units. Okay, how about this one? Once again, angle bisectors, so I know I'm talking about the incenter. Therefore, I know that HN is going to be the same length as HM and as HP. Excuse me. So what I did here, over here, guys, is I broke out. You see, I got this triangle right here. Got this triangle. So I'm just going to look at that. Oh, look, I know how long the hypotenuse is. It's 25 units. One of the sides is 24 units. So I can just use the Pythagorean theorem that says a squared plus b squared equals c squared. And let's see, I got 24 squared, and I called that other side x squared equals 25 squared. And if you go to the trouble of solving that, you'll find out that x equals 7. And that's what all those lengths are, 7 units. By the way, that's called a Pythagorean triple, a right triangle whose sides are all integers, whose side lengths are all integers. We'll talk about those, I think, in the next unit maybe, Pythagorean triples. Okay, so there you go. Okay, all that's left here, I believe, for you to finish is to construct the circumcenter and incenter. So on these triangles, I want you to construct the circumcenter of all three of those. And over here, I want you to do the incenters of these three triangles. So what are you going to do? Circumcenter, remember, is perpendicular bisectors. The incenter is angle bisectors. And of course, if you do a good job, all those bisectors for each triangle are going to intersect at your circumcenters on this side and your incenters on this side. And you better do these because I am going to check them at the beginning of the next class. Okay, constructions. Time to get out your compass and straight edge and refresh your memory. And that's it. So please keep up with those flashcards, and we'll see you next time.